Alright, we often get questions about composite and laminate support in Femap, so I'm going to go ahead and take the basic meshing or manual meshing model I made yesterday and go ahead and update it to show some laminate support and how we handle these things in Femap. First thing you need with the laminates is you need a 2D orthotropic properties. The default the default material in Femap is isotropic, so we'll just change that to 2D ortho. And I looked up in an old NASA report a IM6 tape laminate, so 23 e to the 6th. The transverse stiffness 1.29 e to the 6th. And then the G shear modulus, make that about 630,000. And then don't worry about that. Actually, no, we'll just put in some transverse shear stiffnesses that are pretty low, and then a Poisson's ratio of 0.37, and we got some stress limits in this document I pulled up too, so I go ahead and type in some of these numbers just for failure theory things later on. So sideways and compression, or longitudinally, and then transverse, not a lot of strength that direction obviously, and 203,000 compression. And then compression's better, and then a shear strength in this document I see of that. So that ought to help us get through this, and I guess we need to get a density on this. I think a laminate is a little bit lighter than an aluminum, so we'll just go half. There we go. So we got our material in, and the way we handle laminates in Femap is you need to specify the layup. So what I'm going to do now is just create a new layup, and we'll pick our material we just created. And I brought up this entity info window just to show you some neat things we do with laminates over here. So the thickness of the ply, we'll make this one at 45, the next ply at minus 45, 0, 90. And then what we'll do here, let's just reverse these and then also make it symmetric. Press this button here, and you'll see that basically just did what I just said, popped it around. But the nice thing we do is we're actually calculating as we go here the stiffness information for the laminate. So you kind of get all your ABD matrices, your kind of in equivalent properties, isotropic like properties. So there's our layup. So go ahead and save this. Let's just call this 8 ply, and I'll hit OK. And for now, let's just create our property that connects to that. So we'll go to a laminate property. We pick our layup. We'll just call this 8 ply property. And then we'll give it bond shear allowable. And we'll just pick a failure criteria here and say OK. So this actually creates the property. Now the other thing I would do is, what I'm going to kind of do in this model is let's put a stiffened longitudinal property right around with our beams, and then go to a thinner kind of web out here away from these beams. So I'm going to create a second one now. So let's just go in my layups, and I'm going to copy that layup, and then I'm going to edit the copy, and let's just give it a, call it 12 ply, and then let's go down here in the middle and insert some 0 degree plies. And let's move that down so he's in the middle there, and let's duplicate those 2 plies and move them down into the middle of the layup. So now we've got a lot stiffer in the one direction. We can see the stiffness went up a lot. We'll say OK. We'll also copy the property. So you say copy, and then we'll edit that property to point to the new layup. And I'll change its title so I know what it is when I'm picking it. So let's go update our model to use this stuff. And what I'm going to do now is, instead of, I could do the whole model, but let's go ahead and just delete a lot of the model. Then we'll just update a section of it, then copy it back around again. So I'm going to do a delete model mesh and kind of just pick a polygon pick here in Femap and scoot around here. And this will kind of get that section. So here's the stuff that's going to get deleted. Now I don't want to delete a couple of these pieces here in the middle, so let's go remove from the selection. I want to remove these guys. And let's see who's getting deleted now. Okay, I think everything I want to stay is staying, so I'm going to go ahead and say delete that stuff. And it doesn't really matter, there's some of the stuff still used. Oh, and I did miss some other guys here, so delete model mesh. Get rid of the little triangle connectors and beams and stuff that are, I guess they didn't go enough into the center. And do I need him? Yeah, because I'm going to copy that around. So get rid of those. Do the same thing at the bottom. And there's a beam and a plate there, so we're getting them both. And let's get the beam. Say OK. And now I'm down to my little eighth of the model section. And what I want to do is just stiffen up this middle here with that thicker laminate and then put the thinner one out here. So I need a couple more elements here. So I'm going to do this mesh editing edge split and just double down my mesh density through here. And since this is a radial model, I want to get those nodes right on the same correct radius. So I'm going to update their radial value. Move to node. And just pick those nodes, because they were just linearly in between those other ones, not on the curvature. So let's update their radial value to be exactly 12 and just update the radius. You'll see them pop right out where they belong. So what I'm going to do now is just make these elements out of the stiffer laminate and make this out of the thinner, not as stiff laminate. So the easy way to pick, let's turn off the things I won't be picking. And what I want to do now is just do a modify, update elements, and I'm going to change their type and just box pick here. And there I'm getting highlight there. I'm just going to update the type of these elements and make them out of the thicker property. And you can see their color change there. And I'll just go back to the previous command. Let's just do the same thing for this batch of elements, the ones on the outside. We'll make them the thinner laminate. So there we are. And just to make sure of that, let's just change some colors around and visualize this better. Change the color of him. So there, definitely we got the right properties in there. Let me turn back on my other pieces. So now what we'll do is just copy this around like we did before. And we'll do a mesh rotate elements. I'm going to select everybody. And just like we did in the manual meshing example yesterday, we'll just rotate them about the z-axis. And just pop back there. And we want to go 45 degrees. So now everything's kind of rotated around, and let's just connect it all up again with a coincident node check. Select them all. Preview them just to make sure it makes sense, and it certainly does. So we'll say merge them. So now we've got a laminate model of the same pretty much structure. I think I still have my old results in here, so we can see kind of the stiffnesses that were in there. Go ahead and just delete all these results. And let's go ahead and run this just to preview. And I'm actually going to making a mistake here on purpose so you see it. But I'm going to preview the input file, and it tells me errors have occurred. And there's a bunch of laminate elements where the default material direction has not been defined. So Femap's warning me before I write the Nastran file that the laminate 0 degree direction for all the laminates in this model has not been defined. So I need to go set that up. So let's just go turn off everything but laminates, and there's a nice command, modify update elements, material orientation, and I'll pick all those guys, and let's align the 0 degree direction with positive Z. And you can always verify that by turning on the material direction and seeing, and this is what you know the ply, like the 45s and the minus 45s and things I typed in, they're relative to this direction, and you need to really define that to know exactly which way your laminate is officially defined. So at this point, turn everything back on. And actually, we'll get rid of those little angles, don't really need that. Just a nice verification check. But at this point, we can go look at our updated Nastran file and see that our laminates are in there, my plates are in, and here's their material orientation baseline. The beams are still in there. And I think the laminates will be back up here at the top, but here's my P-comps in Nastran defining those layups. So everything looks good to go. Let's go ahead and just analyze this again. I think Nastran finished already. Just going to just wait a couple seconds to get the results in. And so let's go back and look at the first mode. You see this thing stiffened up a little bit, which kind of makes sense. We kind of made the design a little bit different, but there's a laminate run of the model with Femap.